So Andrew Skoog here, Machinist X, doing a series on kind of the basics in machining world, different things. This one's on tool holding in a rotating environment, so milling. Mostly what we're going to be showing, I'm not going to show the tapers of the tools. There's many different tapers from Cat 40, Cat 50, HSK, 40, 32, so on and so forth. I'm not going to spend any time talking about the different tapers in this one, just the business end of the tool. And there's several different types of tool holding, from collet chucks to end mill holders and hydraulics and whatnot. For this one, I'm just going to show you the very basics and the most common. There's three. And then there's different types of them, but we'll get into that later. So I'm going to show you right now what an end mill holder is. An end mill holder is a basic tool holder like you see here. It has a set screw that tightens down the tool in, basically it just tightens down the tool inside, so to hold the tool in. Most end mills that are made for this have a weld and flat, which is a little flat on the shank of the tool, so that this end mill interface, or this set screw interfaces with that weld and flat, allowing the tool to stay in position while you're cutting. They're not as accurate. They're kind of old school. This was some of the first technology that came out when CNC machines came, or even before that, when there was just drill press and somebody wanted to have a longer reach, they would drill a hole in something, put a set screw in the side, and that was how they would hold the tool in. So this is older technology, end mill holders. Then there's collet chucks. This is just a ER20 collet chuck. ER is a standard built by, I want to say it was Ericsson that started the whole thing. Doesn't really matter, it's an industry standard called ER, and there's several different size ERs, all the way from, ER8 all the way up to ER40, ER50 maybe. That doesn't really matter too much. The technology is all the same. They use a spring collet. It's just a spring collet that holds the tool in to this particular collet chuck. So the collet chuck itself would have a cap that would come off of the tool. You see an internal taper. The collet goes into the taper, actually goes into the cap, and then the cap goes into here, and you thread this on, and with the collet inside there, the tool's inside the collet, you torque this down, it transfers the clamping forces and makes a solid tool holder. These are kind of the next advancement after a end mill holder. These were a little bit more accurate, but they had some difficulties in clamping forces, so the technology kind of is still out there and it's very prominent today, but it's just not as accurate as most people need today. And then there's some limitations with, like I said, the clamping forces and runout. So the runout is very important. But these had better runout a lot of times than you would get out of an end mill holder. Subjective, obviously. Then there's heat shrink. So heat shrink is essentially, looks like an end mill holder, but it uses thermal heat to expand the bore, and then you have tight tolerance tools that go in the bore. And you can see this one here is purple. It's been heated up and been used to expand, and then you put the tool in the tool holder and let it cool down, and it grabs that thing 360 degrees. It's extremely robust, very good clamping force. There's a lot of benefits to heat shrink. There's some disadvantages, obviously, because the tool and the holder are basically one at that point in time, but there's some harmonics that come into play. But essentially those are the three main types. And then you have hydraulic, which uses a membrane inside the tool holder with fluid, and when you torque the screw, there's usually a tangential screw that comes with it. You torque that screw down, it puts pressure on the oil, and that oil collapses the sleeve, thus grabbing the tool. And then there's different types of collet chucks. There's a system out there that uses a press to push in a collet on a 50-to-1 taper, I think is what it is. and those are very accurate. Those would be similar to heat shrink in their ability to give good runout and good gripping force. And then of course there's drill chucks and things like that. But those are the main tool holders that you'll find out in the industry. So if you have questions on this, you can always find us at machinistx.com. We don't get into any kind of pushing one person into any type of technology. This is just mainly to get you exposed to the different types of technology. But hope you enjoyed this video. Let me know if you got some other suggestions we can do in the future.